Look at this equation. X to the power of 4 minus 5 times x squared plus 4 equals 0. At first glance, a fourth-degree polynomial, often called a quartic equation, can seem daunting. You might worry that you need to use synthetic division or hunt for rational roots using trial and error. However, look closer at the exponents. Notice that all the powers of x are even numbers. We have x to the power of 4 and x to the power of 2, and the constant term 4 can be thought of as x to the power of 0. Because there are no odd powers like x cubed or just x, this equation has a hidden structure. It is what mathematicians call a biquadratic equation, or simply quadratic in form. Watch as we unlock this equation using a method called substitution. We will introduce a temporary variable to make things easier to see. Let us define a new variable u and set it equal to x squared. If we square both sides of this definition, we see that u squared is equal to x to the power of 4. Now see how the original equation transforms. We replace the x to the power of 4 with u squared and the x squared with u. The equation morphs into u squared minus 5 times u plus 4 equals 0. Suddenly, the problem is much simpler. We are now looking at a standard quadratic equation that we can solve by factoring. We need to find two numbers that multiply together to give the constant term positive 4 and add together to give the middle coefficient negative 5. The numbers negative 1 and negative 4 work perfectly because negative 1 times negative 4 is positive 4 and negative 1 plus negative 4 is negative 5. We can now write the equation as the quantity u minus 1 multiplied by the quantity u minus 4 equals 0. By the zero product property, this implies two possibilities, either u equals 1 or u equals 4. But remember, we're not done yet. The question asks for the values of x, not u. We must now reverse our substitution. Watch as we replace u back with x squared. This splits our path into two separate equations. X squared equals 1 and x squared equals 4. To isolate x, we take the square root of both sides for each equation. This is a critical moment where many students make a mistake. When you introduce a square root to solve for a variable, you must include both the positive and negative roots. For x squared equals 1, the solutions are x equals 1 and x equals negative 1. For x squared equals 4, the solutions are x equals 2 and x equals negative 2. Therefore, we have found 4 distinct real solutions. If you enjoyed this explanation, hit subscribe and check out our other math videos.